Hello, this is part 2 of lab 4. Now we're going to go to simulation mode in order to see how the packet flows within our topology. We're going to simulate and observe the changes of MAC addresses at every stage. Here at stage A, stage B, stage C, stage D, and stage E. So in order to do that, we're going to use the simulation mode of packet tracer. So we go to simulation mode here. Simulation, we click on show all none. Now let's edit the filter. So we want to see the evolution of ARP and ICMP, that's ping requests. So you make sure you check that ARP and ICMP. When we've done that, we do that because we want to see echo request and echo reply messages in order to determine where the MAC address changes. So you click here. Now we're going to try to ping. We're going to try to ping PC2 from PC1. So you click on PC1, desktop, command prompt, ping. What's this IP address of PC1? Ping 10.1.2. So let's try to expand this. Say it's on ICMP. So it says ping is not working, so it means we need to configure a default gateway. Let's check the default gateway on this PC. So you see there's no default gateway configured here. We need a default gateway in order to send our ping successfully. So default gateway for PC1 will be the interface here. Let's check. Show IP. Will be this IP. So let's put it in here, 10.1.1.25. Set that as default gateway. Let's see. Okay. Now let's try to ping again. Here we go. Now it works. We see we have two messages here. We have an ARP message and the ICMP. So if you click on the ARP, we have this message because we are leaving one subnet to another. So we are leaving this subnet. Expand this. We are leaving this subnet 10.1.1.1, this subnet, to a different subnet 10.1.3. So in order to do that, this PC needs to know the MAC address of this router. So going back to this, click on the message. So having these two messages, we, as I explained, the ARP message is occurring because we are leaving from one subnet 10.1.1/24 to a different subnet 10.1.3.2/24. So this PC is ARPing for the MAC address of this router here, and this PC is ARPing for this MAC address by sending a ping to this destination, because it doesn't know how to reach to this subnet because it's a different subnet. It needs to pass by its default gateway, which is found on this router using this interface. So what is the default gateway that it uses? Let's see. Yeah, you see here, gigabit 000 10.1.1.254. So the ping passes from PC1, passes through the switch, and passes through this interface, gigabit 0.0/0/0, and that's the IP address of that interface, which serves as the default gateway for this. Now we can see this also in our ARP message. So this is the ARP message. These are the details of the ARP message. So at device PC1, the source is PC1, which is the source IP is the IP of PC1, 10.1.1. This is it here. And the destination is 10.1.1.254, which is the destination of this interface of this router, gigabit 000. So it sends a broadcast message. This is the broadcast message for ARP to find out what's the ARP address, the MAC address, sorry, of this router. Now if you go on the PC1, PDU information at PC1, this is the OSI module information. Now if you go outbound PDU details, we also see that this is the MAC address of PC1, and the destination MAC address is a broadcast address, which is FFFFF. So this is a broadcast address because it doesn't know the MAC address of router 1. So source IP, source MAC address, destination is unknown, which is why we sent a broadcast. So that's it for that. So, but our focus here is to understand what's happening with this message, the ICMP message, that's the ping message. So can click on that. You see the source IP is 10.1.1, which is the source IP of PC1, and the destination IP here is 10.1.3.2, which is PC2. That's the OSI model information. So outbound PDU information, the source IP is this, the IP of PC1, the destination IP of PC2. This is the information, this is the life of the packet at PC1. So these are the details of the packet at this level. So now you can click here for the simulation to proceed. You see the packet is sent. Now, at switch, you can pause very quick. The packet, I took the packet here at, you can see at device 1, S1, switch 1. So, at switch 1, what we see here is the MAC address. This is the MAC address of PC1. The destination MAC address is a broadcast address. And the source IP at switch 1 is 10.1.1.1. The destination IP is a default gateway. So let's check the inbound PDU. You see the source MAC address is that of PC1. The source IP is that of PC1. The target IP, this is the life of the packet at PC1. So the target IP here is still the gateway, which is router 1, because the gateway, the router permits our packet to move from one network, which is this network here, this subnet, from one subnet to another. So the target IP is still 10.1.1.254, which is the default gateway. And the destination MAC address, of course, is still a broadcast. Now, let's see the life of the packet at R1. At R1, the source IP is still this, the IP of PC1. Destination IP is that of PC of router 1, the default gateway. Now on the out layer, this is the in layer. That is packet coming from this end inside this router. This is what's happening. The packet comes in with this source MAC address, and the destination is a broadcast MAC address. The source IP is that of PC1, 10.1.1. The destination IP is that of the router, the default gateway. Now, on this same router 1, the out layers, that is the ARP message going back to this PC1. Now it has found the MAC address of that router, which is this one, 000. That's the MAC address of that. And it sends it back. The destination MAC address is the MAC address of PC1. Now the source IP is the IP of router 1 of the default gateway. And the destination IP is the IP address of PC1. So this is that information in detail. As I said, when the packet comes in, the destination MAC address is a broadcast because it doesn't know that of the MAC address of router 1. The source MAC address is the MAC address of PC1. Source IP address of PC1. The target MAC address we don't know. The target IP address is that of router 1. Now, going back, the destination MAC address is MAC address of router 1. The source MAC address is the MAC address of the router. This is it. The source IP is the MAC address of the router, of this router, is the IP address of this router, and the target MAC address is the MAC address of PC1. The target IP address is the IP address of PC1. So we can confirm that this is the MAC address of this router by going to the CLI of the router. Let's try that. Let's say show interface gigabit 0000. So this is the MAC address of that router. You see, it's the same thing. I didn't change it. It's the same MAC address of the router. So now that we know that this is the MAC address, let's go back to our simulation and let's try to get a ICMP message. Let's continue. So yeah, now we have ICMP message. Let's click on that. So ICMP, which is ping at PC1, the source IP is the IP address, of course, of PC1. Destination IP is that of PC2. We see that now the ICMP message is different from the ARP message because the ARP has taken place and we now have information of the other subnet. We now know exactly how to go to the other subnet. That's why the ICMP message is having as destination 10.1.3.2, which is the IP address of PC2. But when we started when we sent our ping in the first place, our destination here was that of the default gateway, because we didn't know the MAC address of that router. So MAC ARP message takes place first before the ping can take place. That's why whenever you do when you send a ping to test, the first message will fail because of this process. It's learning the MAC address of the device, which is unknown at that point. So let's go to the outbound PDU. We are still at PC1. This is the ping message at PC1. What's the source ARP? The source MAC address is the MAC address of PC1. The destination MAC address is the MAC address of PC2, of router 1. Sorry, that's the default gateway. The source IP is the IP address of PC1. The destination IP is the IP address of PC2. So let's click play to continue. We see here that at switch 1, nothing changes because the switch just forwards the traffic. It switches the traffic. So the MAC address of PC1 is still the same. The MAC address of the router is still the same. Let's check here. The source MAC address is still that of the PC1. The destination MAC address is still that of router 1, because what this switch does is just to forward traffic, just to switch traffic from one device to the next in the same network. There are switches that can do routing, but in this case, in this instance, there's no routing taking place. It's just switching, just taking from point A to point B. So it is why the source MAC address is still this, that of PC1. Destination MAC address is this, that of router 1. And the destination IP is that of PC2, which is the same here at the outbound PDU level. The same, no changes, because it's just switching, it's not routing. So let's continue. So let's see the ICMP message at R1. So click here. We note that the source MAC address is still this. That's the inbound PDU. R1, the inbound PDU. The source MAC address is that of PC1. Destination MAC address is that of router 1. Source IP is that of PC1. Destination IP is that of router 1. Now the out layer, we don't have that. Why is it so? Something is not right. Let's check the ping, if the ping was successful. Oh, so we try to ping this and the reply is destination host is unreachable. So what does it tell us? It tells us that the ping reached has reached this router, but is unable to continue from this router to this router. So, just like we had configured the default gateway for this ping to move from that PC to this router, we need to configure a static route in order to tell our router which direction it should take whenever it receives a packet. So, in order to do that, we will go into the router. We will go into the router. First of all, let's check show run. This will tell us the configuration we have in our router. This is the interface IP. We see that we don't have any static route configured. So any packet that reaches this router will just fail to continue because it cannot be routed because we've not configured any static routes. So in order to do that, let's go into configuration mode. Let's check what are the IPs. What do you want to do? You want to route, right? You want to route. What do you want to route? An IP address. An IP packet. Let's say IP, let's put question mark. IP route. Let's do that. IP route, question mark. So this is the format in which we need to put to do our static routing. So we will do that by inputting the IP address. So we want to create a route to this destination 10.1.3.0 255.255.255.0. So any packet going to this network, to this subnet, should use this this interface. So this command tells this command IP route, we are setting a route saying that we are telling our router that any packet that is going to this subnet, on this router, should use this IP address as destination. So we are telling this router to send any packet that is going to this network, to this subnet, to use this as a destination IP. So we can also, in that same, since we only have this connection to this router, we only have these two routers connected with this serial link. We can set a default route saying that so notice that this IP is the IP at the interface level on this router, the serial 0/1/0. So this is the IP at this interface. So now this command says that any packet that comes to this router, send it through this IP address interface, serial 010. So this was specific to this network. This route was specific to this. This route was specific to the 10.1.3 subnet. And this route is general, saying that any packet that reaches this router, routed through using this interface IP. In other words, saying just like setting a default route, that's the name, default way, a default direction. So we do that and we'll check again to see if the ICMP works now. Now we wait for it to go back. So it's coming back saying that ICMP wasn't working. See. It's saying that ICMP is not working. Now it works. Can pause here. Now, since we have configured static route, we see that we now have outbound PDU here, which we didn't have before. Source IP is this, that of PC1. Destination IP is that of PC2. We are at the router 1 level. So one thing we need to make sure here is to understand here is that well, this is the ICMP details. It's type 0x08. This is the IP version 4. That's what we're using. And this is the encapsulation mode. We are using Ethernet 1, Ethernet 2 as encapsulation. So that is at the router 1 level. On router 2, the destination is still the destination of PC2. Source IP from PC1. Now let's see. Now here we don't see any MAC address anywhere here because the encapsulation has removed that layer. We are using HDLC encapsulation because of this serial link. So this serial link uses a different encapsulation mode, which is not Ethernet. This link is Ethernet gigabit port links. I mean, it's copper straight through links. But here, copper straight through links uses Ethernet 2 encapsulation. This serial link that we uses a different encapsulation, so it cut off that layer which contained because it doesn't use MAC address here. So it could be point-to-point or HDLC. So that's what we're using here. So we use that in order to transfer the packet from this router to this router. Now that the packet is on this router, we're going to use Ethernet again. In order to do that, we have to ARP. That's why ARP is taking place, because now we're no longer using HDLC. We're going to use a different encapsulation to send this packet to PC2. So router 2 doesn't know the MAC address of PC2. That's why it sends a broadcast. So this is the MAC address of router 1 or router 2, but it doesn't know the MAC address of PC2. So this is the IP address of the router. This is the IP address of PC2, but it does not know the MAC address of PC2. In order for it to send a ping message, it needs to know the MAC address so that it will encapsulate it back into this frame, the Ethernet 2, for the ping to move from router 2 to PC2. So that's why here ICMP stops here, because it does not, ICMP stops at this level and ARP continues because it needs to know the MAC address of PC2, because it needs that MAC address to put it in the frame as using the encapsulation Ethernet 2 in order for it to move in this subnet, in order for it to send the ping to this subnet. So that's what it's doing. Let's click, see, PC2 comes back, replies. That's a reply. Now it goes to now you see the ping messages. The ping message is going through. We're no longer getting the ARP. So let's pause this here. So as we saw, when it got the ARP reply from PC2, it got the ARP reply from PC2. So PC2 replied, this is the reply. PC2 replied with, oh, this is my MAC address, sending this to this MAC address of router 2. So the source IP of this packet is 10.1.3.2. This is the IP address of PC2. This is the destination IP. Here is the IP address of router 2. Now we see this ARP, of course, is going through an encapsulation of Ethernet 2. This is the inbound PDU. It was a broadcast because it didn't know the MAC address of PC2. The source was, this is the source of router 2. So the target is unknown. That's the broadcast. Now the source here is the source MAC address of PC2. The broadcast is a the destination MAC address is the MAC address of PC of router 2, sorry, source MAC of PC2, the source IP of PC2, destination IP, the IP of router 2. So here it's the same, it doesn't change, it just forwards the IPs and the MAC addresses. Nothing changes at that level. Now, this is what happens on router 2 when it receives the ARP reply. So the ARP replies comes with the source MAC address of PC2, destination MAC address of router 2, source IP address of PC2, destination IP address of router 2. Now after that, it sends it directly. It sends a ping directly to PC1. Source IP we are PC1 here. Source IP is this. Destination IP is that of router 1. Source IP is that. Destination IP is that of PC2. At this level, it just forwards the packet. So here, this is the inbound PDU at router 1. Source MAC address is that of destination MAC address is that of router 1. Source MAC address is that of PC1. You notice that the encapsulation here changes. This is Ethernet 2. On the outbound PDU, the encapsulation is HDLC. It could also be point to point, but we are using HDLC here for that serial connection. So on this level, this is the PDU. It has cut off this MAC address section. So it has cut off this Ethernet, this MAC address section of the frame. Now it doesn't need that to forward that packet to the other router. So this is the PDU at R1 on the outbound PDU level. The destination is that of PC2. The source is that of PC1. You see the inbound here at router 2 is HDLC. The outbound, it changes back to Ethernet 2 because it has to forward that packet through that network with those type of straight through connection. So at router 2, the destination IP is that of IP. The destination MAC is that of MAC of PC2. The source MAC is that of router 2. So that's what we need to understand. There is a difference in encapsulation here. So that's the life of a packet at those different stages. So the most important thing we need to remember here is with the Ethernet encapsulation, like this one for example, it uses both source MAC address and destination MAC address. Also on the ICMP, on the IP level, it uses source IP and the destination IP for this frame. So this is something specific with Ethernet 2 encapsulation. Whereas when we go to When we come here, this is HDLC encapsulation. It doesn't use the MAC address, nor does it use the source MAC address or the destination MAC address. It only uses this source IP and destination IP. That's the main difference between this encapsulation method. Also, this is an echo request message, ICMP. When it's 0 times 08, it's an echo request. For echo reply, you have 0 times 00. The code is 0 times 00. That's the reply. So I know it was a little bit long, but this is very, very key when you want to understand the life of a packet. I think I've done my best to go into the details, so I hope it helps. If you have any question, just put it in the comments, and see you in the next video. Yes.